Wound rotor motor controllers. In this presentation, we're going to be looking at what do wound rotor motor controllers need to do? Old wound rotor motor controllers and new wound rotor motor controllers. Wound rotor motor controllers have three roles. They need to be able to start the motor with the required resistance to generate the required starting torque. They need to also reduce the rotor resistance as the speed increases. And finally, remove the external resistance at full speed. There are two types of wound rotor motor controllers. We have old, which are the mechanical operation pre-1980s, and new electronic operation 1980s till present day. On a standard wound rotor motor controller, we have typically a couple of different setups. The first one we're going to look at is called a definite time acceleration with three rotor resistance stages. Now, definite time means that the time is determined by what we set the timer relays at. And in this particular circuit, there are two, timer relay 1 and timer relay 2, both of which are time delay on energization. If we take a look at the full operation of the system, we first press the start push button, which energizes TR1 and the M coil. Now, as soon as this happens, TR1 starts timing, and the M coil will then operate the M contacts, which causes them to all close. Now, TR1 is still timing in the background. The stator is then energized, and the holding circuit is completed, meaning that we can then release the start push button. The rotor will start turning. AC voltage and hertz will be induced, and we are going to have maximum resistance in the rotor. And that's because CR1 and CR2 are both open. You can see the contacts are open. This is the maximum amount of resistance, and this would give us the largest amount of starting torque. Now, TR1 will eventually complete its timing sequence, and the timed contact will then close. When this happens, TR2 and CR1 will energize. Now, TR2 is another timing relay. CR1 is simply a regular contactor or relay, and when it's energized, its contacts will change state, going to the closed position. Now, this causes the current to flow and bypass set number 1 resistors. The term used to bypass is called shunting. The CR1 contacts shunt out the set number 1 starting resistors. In this way, the rotor resistance is reduced, and TR2 continues timing. The motor RPM increases, and finally, TR2 completes its timing, which causes its timed contact to close. When this happens, the CR2 relay coil energizes, which again causes its contacts to also change state in the rotor resistance circuit. We are now shunting both set number 1 and set number 2, meaning we are now at minimum resistance in the rotor circuit. At this time, the holding circuit is also completed down at the bottom of the schematic for CR2. And that's because the TR2 and CR1 contacts will revert back to their normal positions due to this contact right here becoming opened and de-energizing them. So it's quite a series of steps that take place, but there is a cascading order of operation from top to bottom through the schematic diagram. Another type is a load-determined acceleration time. This again has three rotor resistance stages, but you'll notice it's vastly more simplified compared to the previous circuit. Now, what we mean by load determined is that the size of the mechanical load, will determine how long the starting sequence is. There are no timing relays that we need to predetermine. Sometimes a relay control does not involve the complete de-energization of the coil for contact operation. Instead, the coil rating of the relay is selected so that it will drop the armature at a predetermined value. In this way, the relay coil will remain energized throughout the circuit's entire operation. Again, Remember that when a wound rotor motor is starting, the voltage in hertz when it's first started is very high, and as it starts to increase in speed, the percent slip goes down, and the voltage and frequency on the rotor decreases. This is going to be utilized in the operation of a load-determined starting sequence. In this situation, what we have is something called a frequency relay. And a frequency relay is simply a relay that has a set frequency on it with a dial, or perhaps just purchased for a particular frequency value. The armature is designed to drop out when the rotor hertz drops below a preset value. The relay below is a standard lower dropout voltage than 1A. And so the process should be that 1A drops out first and then 2A. When we first start the rotor or the wound rotor motor, and I'm just sort of bypassing the whole stator side of this circuit, we're just going to focus on the rotor side. When first started, the rotor voltage in hertz will be high. And this means that both relays will be energized with a voltage high enough to seal in their armatures. And that means that they are going to both articulate or open their contacts. And that means maximum resistance will be in the rotor circuit. As the rotor increases in speed, the rotor hertz and voltage will decrease. And at a certain point, this frequency relay will be triggered. The frequency relay 1A, its armature will drop out and the contacts will close or go back to their original position, thereby shunting 3 of the resistors. We are now in a medium resistance stage. As the motor continues to increase speed, the rotor hertz and volts decrease yet again. And finally, we will reach a point where relay 2A armature drops out and the contacts will again close on this relay. Minimum resistance is now being applied to the rotor winding. Another type is a wound rotor motor controller that is used to determine the amount of resistance for this running speed of the motor. This is a defined time acceleration, and users can determine if the motor is started at 100, 75, or 50% resistance. This one has 3 rotor resistance stages. And yet another is to have a forward and reversing wound rotor motor. And all we're doing in order to accomplish this is to add a reversing starter here. All we need to do is reverse 2 phases of the incoming 3-phase to the stator of the motor, and we will reverse its direction. This is an example of a new electronic automatic wound rotor controller, and it's very similar to the synchronous automatic wound or automatic motor controller. It will monitor everything, adjust the rotor current for desired torque, and it will have an external resistor bank if necessary, or perhaps even have a regenerative braking feature where it supplies energy back to the 3-phase bus.